in this chapter, we want to calculate how much energy is released when an ionic bond is formed, and also how much energy is needed to break a bond. Why do we do this? Because at the end of the day, once we know the chemistry of a chemical reaction, we would like to produce chemicals and use them for better living. So we need to know how much heat we should use in a factory to produce a chemical. Or if reaction is heat releasing, we should know how to cool off the reaction tower before it melts. So energy exchange in chemical reaction are of importance. And in this chapter, we are focusing on energy exchange of ionic compounds, formation of ionic compounds. So before I continue, I would like to remind you of what we discussed in previous chapter. So you may remember that we said electrons, which are involved in chemical reactions, are valence shell electrons. We showed you how to use periodic table to have an idea of number of valence electrons. You might remember this slide. Remember, we said that all the elements in group 1A, they all have one electron in their valence shell, and this one electron is inside s orbital. We also said all main group elements, which are in group 2A, they have 2 electrons in the valence shell. And group 3A, they have 3 electrons in valence shell, 2 of them in S, 1 of them in P. Group 4A, 4 electrons in the outer shell. Group 5A, 5 electrons in the outer shell. And group 6A, 6 electrons in the outer shell. And group 7A, 7 electrons. Group 8A, they have 8 electrons in the outer shell. We also said that group 8A are the most stable member of this community. And every other element is looking up to them. So the utmost desire for all elements is to have an electron configuration which resembles electron configuration of noble gases, which are in group 8A. So we also said that if we look at transition metal, scandium, and group 3B, they all have 1 electron in the orbital. So group 7B of transition metal, they have 5 electrons in the orbital. And group 12 or 2B of transition metal, they have 10 electrons in the orbital. And we said that in a transition metal, they have their electrons either in 4F or 5F. So this is just a refresher from previous chapter. So if I go to next slide, is it fair to say that if hydrogen loses 1 electron, it's going to have charge of +1, and all of these metals, lithium, sodium, potassium, rubidium, cesium, they will all lose 1 electron. And then they are going to look like a noble gas. So the charge of group 1A, the ions formed from group 1A metals is +1. Group 2A, they all have 2 electrons in the outer shell. They lose those 2 electrons to look like a noble gas. So the charge of metals in group 2A is going to be +2. And group 3A, aluminum, is going to be +3. Group 4A, Sn and Pb are going to be, they are kind of behave like a transition metal, so their charge is +2. But group 5A, which is non-metal, it will gain 3 electrons. So their outer shell has 8 electrons. They look like a noble gas, so the charge is going to be -3 because they gain 3 electrons. Group 6A, they must gain 2 electrons. So they have 8 electrons in the outer shell. group 7A gain 1 electron, and all these nonmetals are going to have -1 charge. So we kind of expect what sort of charge these elements are going to gain if they become an ion. Metals, as you see, they lose electron to have a positive charge ion. We call positive charge ion, positively charged ions are called cation. Nonmetals tend to gain electron. They make negatively charged ions. We call them anion. So let's look at sodium. This is the electron configuration, complete notation of sodium ion, and then noble gas configuration. It shows neon and 1 s electron. So if sodium would like to look like a noble gas, in this case, closest noble gas is neon, all it has to do is to lose this 1 electron. That's what it's going to do. It loses 3s1. Then electron configuration resembles electron configuration of neon. And sodium ion is a very stable ion. You know, sodium metal catches fire. Sodium ion is part of the ion inside your salt dispenser. It can sit on your table for 2,000 years or more. It's not going to catch fire. It's not going to react with air. It's not going to react with water. Now, how about magnesium? How would magnesium stabilize itself? Well, this is the electron configuration, and noble gas notation says magnesium would be very happy, would look like neon if it loses these 3s electrons. So that's what it's doing. It's gaining +2 charge. Why? It has lost 2 negatively charged electrons. And its electron configuration resembles a noble gas, neon. So this is the stable form of the magnesium ion. And aluminum, which is in group 3A, it has got 3 electrons in the outermost shell, and its noble gas configuration is neon. It has 3 electron excess relative to neon. It's easy to lose these 3 electrons, and then aluminum, which has lost these 3 electrons, has 10 electrons left. It has the configuration of neon, so that's how aluminum makes an ion. It loses 3 electrons. As you see, all metals have positive charge because metals are good electron donors. And again, looking at periodic table, is it fair to say what sort of ion would I expect from all these metals which have got 1 electron in the outer shell? Well, they lose 1 electron. They gain positive charge. How about group 2A? All of them, as you see, they have got 2 electrons in the outer shell. They are going to lose those 2 electrons. So the charge of group 2A is going to be +2. And how about group 3A, which has got 3 electrons in valence shell? The metal of this group is going to lose 3 electrons. The charge is going to be +3. And if I go to group 7, which is nonmetal, they're all nonmetals. They have 7 electrons in the outer shell. The easiest way for 7 to become 8, the shortest way for 7 to become 8 is to gain 1 electron. So the charge is -1. Oxygen has 6 electrons. All group 6A have 6 electrons in the outer shell. The shortest way for 6 to become 8 is gain of 2. So it's going to gain 2 electrons, and the charge is going to be -2. How about group 5A? You write 5 minus 8. So it needs to gain 3 electrons. It makes negatively charged ion. We call them anion. So -3. You see, nonmetals make negatively charged ions. They make anions. Metals make cations by losing electrons.